people, they want to do it yourself kits are there. So what is happening? This DIY kits, na, so those people may not be electronics engineers. They may be mechanical engineer, or they may be a simple lawyer or policeman. They also want to make small things, maybe automatic of garden, automatic lights, something like that. So these hobbyists also were very much attracted towards the Arduino. Then engineers and many scientists and mathematicians, they all started using this Arduino to collect data for sensor interfacing and for programming and DIY development. So this was a very easy chip or very easy module to learn and to use at very low cost. This is a typical Arduino board, similar to my board which I am having on my table here. So if you see on the right, we have a 8 mega pin mapping. So 8 mega is a 28 pin IC. Out of 28 pin, few are power pin and ground pin and few are IO pins. So all the IO pins are connected outwards on this female connectors. Okay, so using a male connector, you can connect the female connector on the board. So on the right side, if you see here, I hope my mouse pointer is visible. Okay, so on the right side, if you see interrupt 1, interrupt 0, that side I'm telling. So 0, 1, 2, 3, 4 up to 13. So 0, 13, 14 input output are possible. We can say like that 14 digital IO are possible. Out of that, 0 and 1 is basically your TX-RX pin. What is TX-RX pin? It is nothing but it is a UART communication pin. What is UART here? UART is a receiver transmitter for asynchronous communication, and it is serial communication. So one pin is enough to send lots and lots of data in serial mode. The thing is, the serial communication has become so important. This Arduino board is giving you two more serial interface. So one is UART interface, which is just a basic serial. Then here you can see pin number 10 to 13. SPI, serial peripheral interface, serial clock, slave, MISO, master in slave output, master output slave input. This is basically SPI interface. And one more serial interface is there, I2C, inter IC communication, IIC, that is clock and data. SCL is clock, SDA is data, serial clock and serial data. So three type of serial communication possible with Arduino here. One is UART, pin number 0, pin number 1, TX-RS. Second is SPI, pin number 10, 11, 12, 13, SPI, serial clock and MISO, MOSI. Then I2C, which is just separate pins apart from your 14 IO, which is nothing but clock and data pin, I2C, clock and data pin at the top. Now, why so many serial communications are there? See, the world has moved to serial. Your SD card in your phone is serial. USB is serial. LAN is serial. When you talk on phone, the data is going serially. When you talk over Wi-Fi, TCP/IP, data is going serially. You talk on fiber optic cable, again data is going serially. So the world has moved towards serial data communication. So many different protocols have come for serial data communication, and Arduino also is in par with that, and it is giving multiple serial interfaces like UART, SPI, and I2C. Again, if you wonder here, there are some signs like a negative sign. It will look like an image, but actually it is sine wave sign. Pin number 3, 5, 6, 9, 10, 11. This sine wave sign means PWM. What is the meaning of PWM? Pulse width modulation. It is an extra feature given by the Arduino chip, okay, for the interfacing. It is a basically output interface. Suppose you want to have a motor and the motor speed you want to control, or you have a heater or bulb and heater temperature or bulb intensity you want to control. Some sound devices are there, you want to make different sounds. So all this is possible with the help of PWM, pulse width modulation. By modifying the pulse width modulation of the pulse width, you can control the intensity of light or sound or motors and generate different sounds. That is the advantage of pulse width modulation. It is almost very near to DAC, digital to analog converter. So even though it is a digital pin, but some pseudo, or you can say fake or nearby analog behavior we can get using PWM pins. Coming to the left side, again you can see analog inputs A0 to A5. A0 to A5 means 6 analog inputs are possible with Arduino. So what is the meaning of 6 analog inputs? 6 AD converters are not there inside. Basically, it is a single AD converter, but we have multiplexing. So for you, 6 different analog sensors or 6 different analog inputs can be connected to Arduino. Suppose you have one temperature sensor, one light intensity sensor, one soil moisture sensor, like that multiple sensors, one gas sensor, like that multiple sensors you are connected. So total of 6 sensors you can connect. If you want more than 6 sensors, then you have to use expansion boards or expansion ICs. Okay. Coming to the left side again, above this analog input, we have V in, ground, 5 volt, 3.3 volt. So these are the power point and then reset. So V in is nothing but what you give input voltage. Ground is normal ground, then 5 volt regulated and 3.3 volt regulated. See, this 5 volt regulated and 3.3 volt regulated, you can use for powering some small sensors, okay, and very, very small motors and displays. But for bigger motors, bigger display and heavy loads, don't use this 5 volt and 3.3 volt. Better to have separate 5 volt supply or 3.3 volt supply for those devices. Otherwise, this much current they cannot give and output may not work properly or input may not work properly if you are using too much power from the Arduino board. Little bit you can use, but too much you cannot use. So I hope you understand what are the pins of Arduino here. Okay, now we'll come some few more parts of the Arduino here. So these are the capacitors. This is the diode reverse protection. These are the regulator ICs, power regulators. This is a crystal. Now this is 𝐕 chip one more, which helps conversion of USB input to serial and serial to USB, a bridge kind of thing, converter kind of thing. What is a converter? Serial to USB and USB to serial. Because your computer doesn't understand serial, it understands USB only and LAN only. So Raspberry Pi, people connect with LAN or Wi-Fi, whereas Arduino we connect over USB. USB packets are little complicated packets, so that Arduino is not having that facility, the 𝐕. So a separate chip is used here. This one, a small chip, a SMD chip, but powerful chip, which converts this USB packet to serial packet and vice versa, serial packet to USB packet, so that the programming is possible and debugging and serial communication also possible. I will show you how serial communication is possible between Arduino and desktop or laptop. I am using the desktop here today. Okay. So to summarize here, the features of our Arduino board or Arduino chip is 14 digital IOs, 0 to 13, as we have seen, 6 analog input, 6 PWM pins. So please understand that the 14 digital IO only consists of 6 PWM pins. It's not separate, but 6 analog inputs are separate. USB serial, 16 megahertz is your clock speed, 32 KB flash memory, 2 KB your RAM, 1 KB EEPROM. Now what is meaning of this? You have to understand. 16 megahertz clock speed. Any of your phone, if you take, they are 2 gigahertz, 2.4 gigahertz, like that clock speed, gigahertz. Your desktop will be 3.2 gigahertz, 3.5 gigahertz, like that. Now coming to flash memory, nothing but code memory or data memory. You have 1 TB hard disk or 64 GB of memory for photos and other things, or 128 GB of memory, GB again, or TB. But here we are talking in KB, just 32 KB. RAM. Any phone if you take, 4 GB RAM is nowadays very common. Laptop also you take 4 to 8 GB RAM is very common. Okay. But here only, not even MB, it is KB, 2 KB RAM. So whatever application you are writing, your application should be very, very precise and very, very focused way. Okay. So what you really want to do, that much only code you have to write here. So other things it will not do, it will do only one thing which you have written the code for that. And 1 KB EEPROM, suppose you want to save some configuration, some password, some values, some locations, those 1 KB memory can be used, because whatever you store in RAM, once you switch off and switch on, the data will go away. So for important data which should not go away after switch on, then you have to use EEPROM. Now the Arduino comes with a IDE, a free IDE, open source, and that can be used to program the Arduino, write the program, compile the program, and dump the program. Dump means program hardware, scoping to hardware from system or your laptop or desktop to Arduino chip you are loading. That is called programming, and it is having inbuilt so many libraries. So when we are going to interface DHC sensor, I'll show you how to use a library. So I hope features are clear to you guys. Okay. This is a detailed diagram of the same Arduino board which we were discussing here. Okay. Now we'll come to the IDE which we are going to use. So in this IDE, we have a input and edit area. In this area only you are going to write the code. So you can see that orange color, some things are in blue color. So that is called syntax highlighting. The IDE, one of the IDE job is if any error is there in syntax, it will highlight and tell something is problematic. Some syntax is not correct or brackets are missing, it will tell clearly. Then we have status bar and program notification area. When you compile the program, it will show done compiling. When you upload the program, it will show done uploading or uploading. Program notification area also gives you detailed messages. Okay, like how much RAM you have used or what kind of errors are there. Then we have button bar and menu bar in which you have access to all icons and buttons. This is the Arduino IDE. Very simple IDE to use. Compared to 𝐶EL, used for 8051 or ARM, this is very simple to use. Now we come to structure of Arduino programs. So as you know, any kind of embedded system has an infinite loop, like your washing machine, microwave. Always they are waiting for button to be pressed. Even your phone also, always it's waiting. Any call will come, any SMS will come, I'll wake up. The person will touch the touch screen, I'll wake up, or he will show the face or press the power button, I'll wake up. So he's waiting for button inputs, touch inputs. He's waiting for incoming calls or messages. Correct? Infinitely it is waiting. Same way, Arduino programs also, infinite loop is there. That is a loop function. So your main code will be there. Any button press detection, any sensor detection. Okay, if sensor value is high, do this. Sensor value is low, do this. All this is happening in loop. What happens in setup? The initial thing. The initial boot up configuration, when the system boots up, first time, you want to set up some variable names, some variable values, some variable contains. Okay, maybe some for loop I equal to 0, counter equal to 100, whatever you want to decide. Some serial mode you want to communicate, like 9600 baud rate you want, or I2C you want. What you want system or pins to be configured, which pin you want input, which pin you want output. All those things are always put into setup, which happens only once. So that is the setup and loop function. These two functions only will be there mainly in most of the simple programs. Okay. Now, what is the process of writing an Arduino program and loading into the chip? The Arduino programs are called sketch. Okay. After writing your sketch or after writing your program, you compile the button. Once you compile, okay. The beauty of compilation is you don't need hardware. So even if you at home you want to try some programs and compile it, you can at least see that the program doesn't have any syntax errors. Your program doesn't have any normal errors. So just if compiling is happening successfully, your 80% work is done. Okay. Now, when you click on the upload button, okay, you will see there is one TX-RX LED. So you can see in this video also, I can show you one LED is blinking, and near to that only one TX-RX LED is there. Okay. Now this TX-RX LED is basically communication LED, and in any packet which is going transmitter side, the TX will blink. Any packets coming from the receiver side, it will blink. Okay. Any packet means simple data also. So this TX-RX LED will simply blink. That means your program is under uploading process. And once your program is over, and based on your program, suppose you written a program for blinking LED or making a sound or making motor run, all those things will start happening after blinking is over and message comes done uploading. Okay. Now, this slide is very important slide. Till now, whatever I have talked was just pure theory. Now, if you understand this slide, which is the current slide which is shown, which has pin mode and serial functions, if you are able to understand this slide, your 60 to 70% of code will be from this only. Only logical expression and playing with the values that you can do outside this function. Apart from that, these are the main functions useful for Arduino to interface with the outside world. So first thing is pin mode function. Any pin 0 to 13 or A0 to A6, either you can use as an input pin or output pin, but you have to tell before Arduino, because Arduino will configure the pin accordingly. If you don't tell it, it won't be configuring it properly. So input pin or output pin you have to tell using a function called pin mode. Okay. Now there's a confusion here. LED1, BT1, LED1, BT1, like that functions are written. Digital write, digital read, pin mode. Okay. Now how Arduino will come to know which LED1 is talking, which BT1 is talking. So if you see last two statements, you can define any pin number as a variable. So pin number 4 I have defined as BT1. Pin number 13 I have defined as LED1. You can define pin number 12 also. But pin number 13 I choose for LED1 because in Arduino board there is an inbuilt LED which is of almost orange color or red color. Yellow and orange color mixer. So that LED is basically pin number 13 connected internally. So LED1 I am defining as 13 pin, which is nothing but inbuilt LED. Okay. So instead of using directly pin numbers in the code, if you rename them as a variable, it is always easy to assign them, easy to use them, easy to modify them, and easy to track them. Again, coming to first statement, pin mode, LED1 output. The meaning of this statement is from now onwards, LED1, which is nothing but pin number 13, will be considered as an output pin. You can write into that, but you cannot read from that. Pin mode BT1, input underscore pull up. Now this is an interesting concept of pull up here, which few of you will know and few may not be knowing, so I will teach them now. Okay, what is the meaning of pull up? Okay, if you see, suppose this is IC, okay, and this is some pins in the IC coming out. Okay, now you have connected some sensor here. Sensor gives 0, pin will read 0. Sensor give 1, pin will read 1. Okay, but suppose sensor is not connected, what pin will read? Depending on what is connected. Okay, so some pins have option. You can connect one register like this to VCC. So VCC. Okay, so what is the meaning of this? One register is now connected. So I'll just put it as an R to VCC. Now whenever pin is floating, this register will have a current here, voltage here, and the pin will by default work as a high. So I write here 1. 1 is the default value. Sensor connected, not connected, 1 will come also, always. So suppose some switch is pressed, or sensor some output is 0, then only it will read 0. Otherwise default value is 1. So default value is 1. That is the advantage of pull up here. Noise will not come and pin won't be a floating pin. Sometimes some ICs will have option to give you pull down. So from here you can have register and that register will going to ground. Okay, that is called pull down register. So concept of pull up and pull down is simple. That in pull down default value will be 0, and when a sensor gives high 5 volts, then the 5 volt current will come, it will drop against this register and you will get the output. Pull up register default value will be 1, so always your pin will be reading 1 1 1 1. As soon as this is connected to ground, then only pin will be reading 0, ground or 0 volts. That is the idea of pull up and pull down. So we have enabled here pull up register. Also, some of the sensor output is a do output, either it is open or is a ground. When it is open, then you cannot read such value. They will not give 5 volt and 0 volt. They will give open and ground. If that kind of sensors are there, also called open collector sensors or open collector pins or open collector outputs, in that case also pull up register is must. So that's why it is always advisable to enable the external or internal pull up. External pull up will increase the board connection. You have to connect one register, solder it, or you have to use a breadboard. So better is for simple projects, internal pull up register to be enabled. Okay. Next function is digital write. So pin mode we have understood. Now we come to digital write. So in pin mode, we are told some pin is input, some pin is output. So whenever pin is a output pin, then only digital write is possible. And what you can write, either high or low, 0 or 1. So here is example, digital write LED1 high, followed by digital write LED1 low. So if you want to make LED high low, you can use this function. Not only LED, DC motors, displays, then some buzzer, some relay, all those can be controlled with only digital write is enough. Then comes digital read. Suppose you want to read the status of a button or read a status of sensor, maybe light sensor, all motion sensor, just status. Okay, then you can use digital read function. If the output is 0, sensor output is 0. If output is 1, sensor output is high. Okay, so with this, digital input output is possible, and pin mode and digital read write functions are enough to communicate outside the Arduino digital input, digital output seamlessly, very easily. Now some hardware are complex, like RFID reader, GPS, Bluetooth. You might have heard about this hardware. Okay, GSM modem for sending SMS, GPS for getting location, ZigBee for wireless communication, Bluetooth for wireless communication, RFID for your toll gates and normal attendance and security. So all these devices works on serial module, works on serial communication, works on serial interface, and this is a special serial interface called UART, Universal Asynchronous Receiver Transmitter. It is a simple serial communication in which there is no clock because it is a asynchronous communication. So first, because it is asynchronous communication, both the parties, means transmitter and receiver, source and destination, should always tell to each other at what speed they will communicate. So both are configured beforehand at same speed, same clock levels. Okay, because in this only is a one wire communication, transmit to receive. No clock signals are there. If you want a duplex, then you need a two wire communication, transmit, receive, receive, transmit. Ground is always required to be common between two circuits. Because this is digital communication, ground is required. So serial.begin, just a simple function to configure the chip to 9600 baud rate, 4800 baud rate, 11520004 baud rate. What is the meaning of this? Because this is asynchronous communication, the baud speeds are fixed from 300 bps to some hundreds of kbps. Out of these few numbers only you have to choose. Okay, out of so many numbers like 300, 600, 1200, 2400, 4800, okay, 56700, all these numbers, 9600 is most common and very famous baud rate for standard serial communication. Now we have some function called serial.write data, serial.read, serial.available, and serial.print. Serial.print is for sending the text lines to computer or to the hardware. Okay, serial communication is also useful for communicating with PC and the laptop. So Arduino can send data to laptop, and laptop can send data to Arduino. Again, I am telling laptop and desktop same interface. So when you want to send some data in a string format, you can use serial.print. If you want to see if any data is available or not in the buffer, because there is a buffer in the RAM which stores the serial data temporarily. So serial.available you can use function. If one comes, means that data is available. Then serial.read, you can read the data from buffer, and serial.write is you write the data in buffer. Why buffer is required? Because serial communication is very slow, CPU is very fast, so CPU cannot wait for one bit by one bit by one bit by one bit. What it will do, it will send data, do other work. Once data is over, it will send next data. So till one byte is going, which will take 10 milliseconds. Why I am telling so confidently 10 milliseconds? Because one bit goes at 9600 baud rate. For serial communication, we have a bit called start bit, end bit, and 8-bit data. So 10 bit is going. So almost nearby 10 milliseconds, it will take to transfer 10 milliseconds of any data. So 1 byte transfer will take that much time. Okay. So serial.read and serial.write are your basic function for writing single byte and reading single byte. But we'll be using this less, the above one more, which is called serial.print. Now digital read write is over, serial read write is over. Now analog read write. This is the third function, analog read. So pin number A0, A1, A2, A3, A4, A5, A6. This sorry, not A5, A6 up to A5. This 6 pins you can easily use for any analog interfacing. Whatever you read, it will come and get stored in your variable. You want to write, you can write also, but you cannot write in same pin. You have to write in PWM pin, which we have discussed in previous slide. There are 6 PWM pins. Out of those, any one pin you can write analog data, but this will be not true analog data. It will be pseudo analog data, or you can say nearby to analog behavior, not exact analog behavior. The output value is only passable 0 to 255 because this is 8-bit PWM. Okay, whereas the analog input output will be 16-bit. So 0 to 16-bit number is, sorry, 10-bit ADC, not 16-bit. So 10-bit ADC is 1000 to 1024. ADC is 10-bit and PWM is 8-bit. So before this is the end of our theory slide. So before going to Arduino practical, let me tell you about the 10-bit and 8-bit system. See, when you talk about 8-bit, the maximum range possible is 256. What is the meaning of that? 00, 01, 02, like that it goes to 256. When you talk about 10-bit number, you can go from 000 to 001, like that 002, like that it goes up to 1024. That is the maximum number. Okay. Then there is a point comes of quantization. If 0 to 5 volt is divided into about 256 levels, so what will be 1 byte, 1 bit, 1 count? So 256 divided by, sorry, 5 divided by 256. Okay. Okay. 5 divided by 256. So we get this much into 1000. Why 1000 I am doing? For millivolt. 19.5 millivolt. 19.5 millivolt will be 8-bit number. Now we come to 10-bit. Same story. So 10-bit means 5 volt. 0 to 5 volt is input range. Output is 0 to 1024, 10-bit number. So 1024. So it is this much voltage. So we'll multiply 1000 to convert into millivolt. 4.88 millivolt. So we can take as 4.882. So 4.83. So 4.88 only. 4.88 millivolt is 1 count. Okay. So what is the meaning of this? Now we'll understand what is the meaning of this. Suppose this is the IC. This is the input. Now to this input you have connected 0.5 volt. What will the output? What will the output here? So as we understood that 1 count is this much. Okay. So 4.88 into 10 millivolt, 48 millivolt, correct? Still it is not enough. So other way we can do it. So I know the resolution 0.5 volt divided by 4.88. 1 second. If 1 count is 4.88 millivolt, so for 0.5 volt, how many counts? So 0.5 volt divided by 4.88 millivolt, but we have to convert that 0.5 into millivolts. So into 1000 divided by 4.88. So 102. So what I'll get? 102 as the output in the variable. So if my input is here 0.5 volt and I'm reading in a program using which function? Using analog read function. That time what will happen? I'll get 102 number. Same way, if I'm reading 2.5 volt, then I should get nearby 512, the half number. And if I read 5 volt, if I give here 5 volt, then variable value should be equal to 1024. Okay, but you will not get 1024. Why? Because starting from 0. So you will get basically 1023. 1023. And this range also is not 1024, it is 1023. Okay, because starting from 0, not starting from 1. So this is the analog input, and this is the digital value you are seeing in the code, you are seeing in the variable. Okay. Now coming back to this function, I hope everybody of you have understood all the functions. So 3 functions are there: digital read write, serial data, serial print, and your analog read write. Okay. If any doubts are there in any of these functions, we can take 1 or 2 doubts, then we can go ahead for the practical coding. Okay, it seems we don't have doubt. It's a pretty simple thing also. Okay, so let me go to the.
Excuse me, sir.
Yes.
Am I audible?
Yes. Yes.
Sir, I joined in a little late, around 3:15. So
Okay.
can you please explain the connection of Arduino if you have explained it already?
Wait, I'll go to the first slide. So we started from here about the, like what is the today's thing which we are going to do. Then
Yes,
I
sir,
told
I have
about
all the materials.
this pin diagram. So you have seen this.
Yes, sir.
Okay, then you have not missed anything much.
Actually, I want to do it right now. That is why I was asking कि कैसे
What?
connections
Can you
करें मेरे
repeat your
पास सारा
question?
सामान है. सर मेरे पास सारा सामान है अभी. I
Okay.
wanted to do it right now. इसीलिए मैंने पूछा था. Please continue.
Okay, you have installed.
Yes, sir. I have the application.
You have installed this Arduino. Okay. Second thing,
Yes,
do
sir.
you have you connected like this Arduino to the USB cable?
Yes, sir.
Okay. Okay, then you can do along with me. If like some of you, if they have hardware, they can do along with me. Okay. But only thing is, we have to complete syllabus, so we may be going a little fast. Okay. So okay, fine. Okay, coming to Arduino, I'll just close it. When you open the Arduino, default comes like this. Is my screen visible?
Yes, sir.
Yeah. Okay. So as I described in theory PPT, we have 2 functions: void setup and void loop. Okay. So all your initial things, configuration thing, initial setup will go in void setup, whereas the thing which is happening continuously again will go to void loop. Okay, that is simple. Now let me open one example. So Arduino has lots of examples, from basic, digital, analog, communication, control, sensors, display, strings. So many examples are there. Okay. Go to basic, click on blink example. Okay. Now when you go to the blink example, there is a setup in which I'm telling pin mode, LED built in, which is nothing but pin number 13 as output. And then in loop, digital write, LED built in, high, then wait for some time, delay 1000 milliseconds. This is millisecond. Again digital write, which LED built in, low, again wait. See what happens, 2 time wait is required. When you make it high, you have to wait for some time. Then when you make it low, again you have to wait for some time. If you don't wait, what will happen? Your LED will be in one state only. So you became high for some time, and then you become low for some time. again you became high for some time. Okay, so all these states are very much required. So in this LED will be on, in this your LED will be off, and in this again LED will be on. So this wait after every state is enough, required, compulsory. If you don't give, then suppose you don't give this delay, what will happen? LED will become high, it will remain high. LED will become low, but it will not become low, again loop will go, again it will become high. So it will be low only for some microsecond, and humans are very slow device. Humans' eyes are not so fast. You cannot see that low. You will see LED is always high. But actually what is happening? LED is high. Okay, then LED becomes low just for some time, and then again LED becomes high. Again your LED becomes high. So what is happening? You are missing that. There is a small low part you are missing because you have not put enough delay at the lowest state, which is one of the common problem. People see, this is simple example of LED blinking. You think in a practical problem. You want to make a sound using a relay. You make the relay on, and then you don't give a delay, and then you make a relay off. Then there will not be a sound. There will be no motor. There will be nothing running, because if you don't give a delay at the proper places. So delays are very important. Okay. So I hope in my second hardware you are able to see this blinking of LED, which is at 1 second net. 1 second on, 1 second off. So what I'll do, I'll just make it 100 millisecond on and 100 millisecond off, and then I'll upload the program by clicking on the right arrow button. See, in this down, compiling sketch, now uploading, done uploading. I got the message here, done uploading, and also I got message like this, sketch uses 922 bytes only, which is 2% of program of 32 KB program memory. This is 32 KB program memory, and variable I have used only 9. Actually no variables you are seen, but actually it is used internally variable, and which is using 202 out of 2 KB. Still this much memory is free, and my LED is now very fastly blinking. So even it's so fast, only it is you are able to see some intensity is getting changed. It's not on off. So I'll make it like little slower, so that at least off on is distinctly. So TXRX, now we can see it's blinking at a normal rate. So at least you can see some off state. Okay. So instead of LED, built-in LED, you can define in various ways. Like this you can define. So what you can do, you can put here LED as LED this one, and here you can use your own variable names. Maybe it is a relay at pin number 7, so RLY1, so RLY high, and RLY low. Like that you can change the program based on your requirement. You can define the variable name based on your requirement. Now we'll jump to a second requirement of button. Okay. This is some description written that you have to connect a push button, you have to connect a 10 register. So what we'll do, we'll use the internal pull up. So button pin, LED pin, 2 pins are defined. You can see button pin is pin number 2, LED pin is pin number 3. Okay, we are going to second program now. Output program you have understood. Now we are going to input program. How to take input from outside world to the Arduino. Button state is 0. Now button pin is pin number 2, LED pin is pin number 13. First, LED pin is output, button pin is input. But what I'll do, because I don't want to do all this 10K register thing. Okay, so what I'll do is I'll just make it underscore pull up. Internal pull up I have enabled. Okay, next is read the button state. Which function you will use? Digital read. Which pin you will read? Button pin, which is nothing but pin number 2. Pin number 2 I am reading. So program, see this all I'll delete, so you are not getting confused. First you are defining the pin, which pin is what. Then some variables you are defining. Initial value you are making 0. then setup will happen only once. So in setup, what is happening? Pin mode, because LED is output, so you make it output. Button is input, you make it input. But internal pull-up I am using because button is a floating device. If you press the button, ground is connected to pin. If you don't press the button, nothing is connected to pin, which is a floating, which is not a good. Okay, so internal pull-up is very much important here. Some kind of pull-up, external or internal pull-up is very much important here. So pin mode, button pin, input pull-up. So this is over. This will happen only once when device boots up. Then what is happening infinitely? Infinitely in a loop function. First I am reading the button state. Okay, if button state is high, means button is not pressed. Button is not pressed. Button is NOT, not pressed. Button state will be high. So LED is high. Button is pressed means pin will be 0. LED will be off. Digital write, pin high. Digital write, pin low. Only button state. But reading button state is happening here. Instead of reading here, you can read here also. You can read here also directly. So both ways it will work. Okay, we will see one by one both ways. Okay, so let me upload the program. So my LED is high because button is not pressed. Why button is pressed means low and button is not pressed is high? So we have to understand the theory of that. Okay, let me clear this. Let me select the black color. So I have a IC like this. I have a pin like this. Okay. Now to this pin, I am connecting one button. Okay, I'll try to make one small button kind of shape. Okay. Now this button I have connected. I'll change the color. Okay. Now this button is going like this and going like this. Okay. And then here we have ground. Here we have a ground. So we make ground. I'll write also ground for your simplicity. G and D. Okay. Now when you press the button from up, okay. When you press the button from top, okay, using your finger, you press the button. Okay. What will happen? This will touch and this will close the circuit. Correct or not? This circuit will get closed. So your ground will come here, 0 will come here. So when you press the button, what will happen? 0 will come here, ground will come here. But when you don't press, it is just a open circuit. It is a open. Simply it is lying in the air. Simply it is hanging in the air. Now what microcontroller will make out? Any chip, not only Arduino, any microcontroller, what it will make out? So when button is pressed, it will read 0. When button is not pressed, it may behave as an antenna. It will pick up noise and randomly it will give values. So we don't want that. So what we will going to do? Either external one register you connect to VCC, the external pull-up, or internal pull-up you make it enable if IC has that features or that facility. So this is nothing but internal pull-up or this is external pull-up or anyone should be there. Then what will happen? If it is open means VCC is coming by register and it is connected here. Then in this case it will read as a always as a 1. But when button is pressed, it will read as a 0. Button pressed, read as a 0. Button not pressed, it will read as a 1. Now this button concept is clear to all. We will go back to code. So button not pressed, pull up is there, it will read high. Button pressed, because of pull up, it will be low. You can go for other way also. If button is pressed, then only LED should become high, otherwise LED should remain off. So my LED is on now. As soon as I load this program, LED should become off. Now LED is off. How to make the LED on? By making button state low. How to make button state low? By connecting the button to ground. So which pin is button? Pin number 2 is the button. Okay. So we can make a small button circuit. Okay. So what I'll do is I'll take this small breadboard, mini breadboard. Okay. I'll connect one line of the breadboard to pin number 2. Pin number 2 is 0, 1, 2. Can you see this green wire which I have connected? You can see in both hardware. Okay. So I connected this green wire to pin number 2, the third pin, 0, 1, 2. Okay. Now what I'm supposed to do is I'll take one more wire from here. Okay. And then a ground I'll take from here. Okay. I have this to my, yeah. So I'll take ground from here. It's written here near V in ground. The second pin from the V in is ground. Okay. So I've taken from here ground. Just above V in, the power pins are there. V in ground 5 volt, 3.3 volt. There only 2 grounds are there. As soon as, so you can see the LED state now. As soon as I connect this ground here on my breadboard, the LED is becoming on. Okay. See, LED is on. What I did, I connected here both the grounds. Okay. So I've simulated the button on the breadboard. Okay. So if I connect simply like here, and I can get a button also. Like this, you will get button. Okay. So what we'll do, instead of breadboard, we'll connect one here, and one more here, and then if you press button, so I'll get, see, on, off, on, off, on, off. So that is simple button function which can be easily used. Not only button, any sensor outputs are there. You can use, instead of button pin, it is just a sensor pin, and digital you have like sensor state 1, like that. You can read sensor 1 pin 1, and you have sensor 2, sensor 3, sensor 4. Multiple sensors are there. Like IR sensor, if you take the proximity sensor, they work simply like this only. When you block the way, it will be high. If you don't block the way, it will be low, or maybe reverse. You have to experiment and see what kind of output your sensor is giving. Okay. Okay. Now coming to next program. Next program, before going to next program, we should understand what is a serial communication. Okay, so let me open a maybe, where is our button program? In this only I can teach you. Okay, so here I can start serial dot S capital, serial dot begin by baud rate of 9600. What is the meaning of that? I'm starting a serial port at this speed. Okay, and there what I'm going to do is serial dot print ln. Ln is for new line. If you don't give ln, it will simply print on same line. I'll just name serial test. Okay. See, I'll put button test, serial button test. Okay. Semicolon. And then if you are, I can tell button not pressed, and here I am going to print button pressed. Button pressed. Okay. But because it is serial communication and at least one will be always successful, then what will happen? There will be very fast data transmission to the computer. So just we'll add one small delay of maybe 500 milliseconds should be enough, half second, and then save the program and then run the program. Saving also not important actually. Okay, done. Uploading has come. Now what we'll do? Tools, serial monitor. Again, I have clicked on tools. I've gone to serial monitors. Now here you can see baud rate is 9600. Click here. You can change any of this from 300. If 300 you put, nothing is coming. Some junk characters are coming because you have selected wrong. Transmitter is transmitting at 9600. You are receiving at 300. It will not work. Even 4800 also will not work. If you go to higher also, it will not work. Correct? So you should both should be in same speed. Now it is working. Again, if I press reset button, so it will run the first part, then it will run the loop part. Correct? So currently loop is running continuously. So let me press the reset button. Serial button test here, first line. Now it is gone. Now how to press the button? Again, many ways are there. So let me just pin number 2, 0, 1, 2. If I connect to ground here, button pressed, button not pressed. This is ground is here also. Button press, button not press. So this is a simple serial communication with feedback. So the microcontroller is sending data. The microcontroller is sending data to computer or laptop using serial communication. Now in here we have two things which you have to see. Tools, serial monitor. So which COM port is connected to COM7? That is very important. If COM number is not correct, data will not come. Baud rate is not correct, data will not come. Okay. Now next is what? We'll try to read some sensor data and try to see on the analog our display. We will see. Now I will try to still analog read is pending, analog write is pending. So one by one we are doing that practical. So our full practicals should be done properly. So we are now good with Arduino coding, how to read the sensor data like digital read function, how to write to motor or LEDs or to buzzers, that is your analog digital write function, and then coming to serial printf. So serial we have just now we have done. Okay. Now simple analog in, serial output is the inbuilt sample. So what I'll do is comment, I'll delete from here to here. Okay. So first we have defined analog input pin A1, then sensor value 0. Start the serial port, serial value, analog read. This is very important. Which pin? Analog pin. Directly you can write pin number here A1. That also will work. But then you will not know which sensor you are connected. So what I'll do is, so instead of sensor name I write LDR IN pin, LDR value. Okay, so LDR IN pin, and this will be my LDR value, and I'll put just LDR value here. LDR value. LDR sensor equal to LDR sensor equal to. So first print without slash n, so it will not go to new line. Slash n means new line. Okay, and then LDR value to print, and after 100 millisecond, or I can say 300 millisecond, it will print again. So let me run the program. Compiling. So you can see while uploading what happens. TXRX, everything will glow, and when done uploading is done, then your job is over. So done uploading. Okay, how to see the output? Tools, serial monitor. So now some value is coming, but sensor is not connected, still its value is coming. What is the meaning of this? That is actually because of the noise. Okay, so I have this LDR sensor here. It has 3 pins, VCC, ground, and A0. D0 also is there, but I'm going to use A0 because I'm into analog testing today. Okay, so this white is ground, then red is 5 volt. Normally I use black and green wires or white wires for ground, and orange, yellow, and red wires for power, and blue, purple, like this, white wires for my signal. And A0 is, A1 is here. Okay, so now I'm getting 150. If I make it dark, value is going down. If I make it bright, value is going up. Okay, let me check. A1. Okay, so actually it's not much changing, so I got a doubt. So I should see a very big difference when I make it dark and light. So it was connected at wrong pin. I connected to A1 now. Now it will be there. So light, dark. Dark is around 1000. Light is around 600. And if I show towards window, it is around 600. If I move towards tube light, it's around 500 kind of thing. But if I go too much dark, it is around 1016, 1018. Okay, so like that I can change this intensity of the light on the sensor. The output is changing. Now this output, as I discussed with you last time, this multiply by 4.8 will give you voltage. Okay, now instead of this you can plot the value also. So tools, serial plotter. So you can see in the graph the value is plotting. So dark is around 1000, light is around 600 to 700. So you can see in the graph. So if you go towards light and light and light and light, maybe torch also you can make on. Let me try the torch on. So flashlight on, oh, not working. Okay, flashlight on is not working now. Maybe this screen. Okay, this screen is little light. Not much light is not there. This LED is having light. Yeah, this LED is having pretty good light. Yeah, the value is going down. Yeah, but if I put hand, definitely it is going up. And if I put it under table, okay, so this is total dark, value is about 1000 only. Now I will come back to light levels. So you can see the sensor graph, how it is changing. So again, how I got this graph? Tools, serial plotter. Okay, so this is the method from which I got the thing. And serial monitor is just a text interface. So both the interfaces of serial communication you might have understood now, and both of them you can use. when you are trying to make a heartbeat sensor, pulse oximeter, or any COVID kind of temperature sensor, that time this serial plotter will be very much useful. So this part, analog sensor interfacing, analog read, I hope you might have understood properly. Serial.print and serial.println and serial.bring also you might understand. Before that, which program we have seen is button program, in which you use pin mode, output, input pull up, digital read, pin, and digital write, again low and high to the value. So these are the basic functions of Arduino, which can be used to communicate with the outside world, whether it is a sensor or it may be an actuator. Actuator will be output device like motor, relay, buzzers, LEDs. Sensors will be like either digital sensor or analog sensor. So let us go for one more sensor, which is nothing but your moisture and temperature sensor. Very famous sensor. It's called DST11. This is a sensor. It is a single sensor, gives both values of moisture and temperature. Okay. First, let me show you where it is and how to download the libraries for that. Okay. So if you write DHT11 and then library for Arduino, if you search like this, okay, GitHub and sensor library, both sites will come. So here like that they have given sensor library is there. There is so many release, latest release, and like that so many releases are there. So 1.4.2, you can click like this, and this DST sensor library will be downloaded. So once you download library like this, you copy the library, into your documents Arduino folder, library. Here you can copy. After copying here, what you do is you go to Arduino, then sketch, include library, add zip library. Okay. So where it is in documents, Arduino, libraries, zip library, correct? Here. Okay. So you can see here library added to your libraries. Click include library menu. So sketch, include library. So just now we have done DHT sensor library. Now it is included like this. But still this is LED program only. So I'll just delete from here. I'll just save it. And I'll go to examples. Just now we downloaded, na? So it will come somewhere here. DST sensor library, DST tester. So this is simple library here. So this is library dst.h. Pin number 2 is used for the input pin. Okay, where DST will be connected. Either DST22 or DST11. So I'll have to change it to DST11. Okay, DST type. Nothing to be changed. So DST pin, DST type, it will initialize one object named DST. So DST2.begin will happen at the beginning. Serial.begin, DST XX test will come. Wait for 200 milliseconds, 2 seconds, that means for stability. Then you are reading humidity, temperature, and then you are printing the values. If sensor is not connected, it will show fail. Otherwise, it will show the values. Okay. These are some extra what you call physical parameter, thermodynamic parameter, which is this printing, like heat index and other things. So we'll upload. First compile will happen, error compiling for the Arduino board. See, because this is Adafruit sensor, so we have to install some Adafruit library also before using this library. Okay. 1 second, I'll open one more DST program. File, open. Actually, here the thing is, all of your program name will start with sketch DST11. Yeah, this one. Okay. Now we have DST here, DST pin number 2. Now I'll try to upload the program. Compiling sketch, uploading, then uploading. Sketch uses 4 KB of memory, 13%, and it uses 300 bytes, 14%. Still, this much bytes are remaining. So you can see, even though we have used a sensor, okay, and we are using serial communication also, then also we are getting that much less, 10 to 15% only we have use of program and data memory. So again, read DST sensor with DST pin number 2, and I'm printing the current humidity value. Just print. See, whenever print is coming, that is not doing anything. It is just printing whatever you print. But where the measurement is happening, when you call this function dst.humidity, it will measure the value, return the value, and that value will be printed. Followed by percentage, that's simply printing. And temperature, simply printing. But here, dst.temperature, actually it will talk to sensor, get the value, and then I'll put here degree Celsius. Okay. Now I'll upload the program. Tools, serial monitor. 00 is coming because I have not connected sensor at all. My wiring is not there, so my sensor is not connected. So let me connect the sensor. Okay. 5 volt ground and pin number 2, 0, 1, 2. Now it's coming. See, temperature and humidity. Now this is the beauty of Bangalore. Temperature is so ideal. It's coming around 25 degrees. For electronics engineer, 25 degrees is the ideal temperature. Okay. Now maybe I can blow into this. At least humidity or temperature can change. So I blown into this hot air. Okay. So you can see now temperature almost reached 30 degrees, and humidity also, because of blowing, it is increased. Now I left it on the table back. So after some time, again it will stabilize to the environmental values. So again, coming back to code, we'll just revise the code how it is connected. So first you have called the library dst.h. Then you tell which pin dst is connected. Okay, you can give 2, 3, 4, A0, A1, A2, whatever you want. Then you initialize the object with name dst, with function dst. So what are the functions available in dst? dst.read11, dst.humidity, dst.temperature. So these 3 functions we are using. Read means you are reading the pin here, dst.humidity, dst.temperature. These 3 places only we are reading. Others just simply are the prints. Okay. Now tools, serial plotter. Okay, already it is open, so we cannot plot it. So tools, serial plotter. Not able to print properly. So what we'll do is, unnecessary statements are there, that will remove. Okay, and this 2 second. Okay, 2 second will make it. Okay, so and this also I'll remove. Now I'll upload the program again. Why I removed? Because so much of data is coming, it is not able to understand which is the number to be plotted and which is the actual value. So compiling, uploading, done uploading. Now tools, serial monitor. Now you can see what is printing. Just values. Just values, correct? Now serial plotter. Already it's open, one window, second window is not allowing to open. Okay, and we have to put somewhere /n also. So maybe we can put a /n here. So Control C. Okay, Control V /n. I can put a space. Okay. And after this also one space may be required, so that system understand it is two different values. So I'll just print one space. So Control S. Now tool, uploading, done uploading, tools, serial monitor. So first we'll see how it is printing. See 6625, 6625. Now tools, I have to first close the serial monitor and tools, serial plotter. So first we have to wait 3 seconds for settling of sensor, and then actually data will start. I should get 2 graphs. Okay, I'll try to increase the humidity. So red line is, say here down, red line is your temperature, blue line is your humidity. Now I left it. Now it will slowly settle down to the required value. So this is the way you connect one sensor and you plot the sensor values to understand how it is behaving in real time. Some sensors like accelerometer and different sensors, you really need to see the data, how really data is looking like, then only you can define. Suppose you are making left tilt, right tilt, forward tilt, backward tilt, okay, rollover, how accelerometer data is behaving, you can see in graph, and then based on that you can write the code. So I hope everybody has understood today's LDR sensor, DST11 sensor, which gives humidity and temperature, how to interface. See, the LDR was analog sensor, whereas DST11 is a digital sensor. It is single wire digital communication. Okay, no one-way communication only. So sensor sending the value, you are reading the value. That's it. LDR was just giving analog voltage. You convert into digital using AD converter, and then print on the serial, this one. So you can do some kind of further coding. If the value is less than this, it is dark. Value is more than this, it is light. All those if and else conditions you can add, and then we can have that kind of coding also. So maybe we can do it now only. So DST11, I hope it's clear to you. We'll go back to our LDR code. Okay, so I'll remove this DST11 and connect the LDR back and load the LDR program. So I'll click to upload function. In ground, then we got here 5 volt, and then we got here pin number A1. Okay, and then tools, serial monitor. So I'm getting this value So around this way, somewhere in the below 700 is somewhere bright side, and somewhere here is dark side. Okay. So we can simply put a condition here. If LDR value is greater than 950, correct, then serial dot print, basically it is a dark. If LDR value is less than 700, then it is bright. In between, it will not print anything. Okay. So I'll make it here bright. Okay. Now we'll upload the program again. Tools, serial monitor. So it is 715, neither dark nor bright, but as soon as so it is coming bright. As soon as I have pointing it towards my tube light, my light up, then showing bright. But if I show it down, still it is not dark enough. How to make it dark? I can cover it, so it's coming dark, bright, dark. So like that, conditionally, based on the condition, sensor values can be interpreted, and instead of putting like this, you can put light levels. Instead of this, okay, I'll save as, okay, LDR1 I'll put. Now again file, okay, file, save as LDR2. Okay, what I see here, what is the backsave number I'm getting bright? Around 620, 610. Huh? What is the minimum number I'm getting when I'm dark? Around 1020, 1021. Okay. So what I can do, I can make a level using a function called map. Okay. Map. Okay. What is the minimum number I got? 600 to 1023 to level brightest is suppose 10 and darkest is 0, and that will be my LL, or I can say light, or I can say level. LGT level equal to this. Okay. Now I can print the light level. Okay, light sensor, light level, what is the light level variable name? It is LGT LVL. Okay, so let us see. So it is telling light level you are not defined, so we can define here only. I can put here only, or I can put at beginning also. Okay, too few arguments. I can first, let me define light level somewhere here, equal to 0, and then I can put here like this. Map long end. Okay, 1 second, one more variable is required. We have forgot to put input value. If this variable is 600, light level is 10. If this variable is 1023, light level is 0. In between, you equally divide the range and give me the output in this light level. Now we'll compile, uploading, done uploading. Tools, serial monitor. Light level 7, light level 8, 9, 10. Okay. Now away from the light. Light level 6, light level 2, too much dark. Light level 1, it has come. Okay. So we can change the light level like this. So to make it more thing, we can remove this, we can remove this, we can increase delay, and then again compile and upload. And this 10 instead of 1023, I can make 1020, so 0 is visible. File, save, again upload. Now it's difficult to get light level total 0. So light level, maximum light level around 10, correct? When I'm showing tube light. If little bit far from tube light, it's showing light level 8. Little more far if I come, as distance is increasing from the tube light, the light level is decreasing. You see, 6. When I'm going, now you can see light level 0, almost nil, correct? So based on light level, now my sensor is now calibrated to show me the light levels. See, it's coming 24 values coming some random sometime, correct? So we can write a code such a way: if light level greater than 10, then you make it 10 only. So you are forcing it to maximum 10. So what will happen? This 24 randomly was coming again, na? That will never come. The noise was coming, that will never come. Done uploading. Now it's coming 7 and 10. The 24, it will never come now. Okay. So this is the way you can not only refer light level, soil moisture level, gas level, pollution level, height, sound levels, anything you can convert into different series. Like sensor output is 100 to 650, range is 1 to 5, like that. Anything you can map from any range to any range. Okay. I hope this map function also is useful to you, and it may be useful for your projects and products in your college time or your startup entrepreneurship time. So I hope we have completed our syllabus. One more thing, as I was telling, if time is left, I will do it. In my PPT, I told at the beginning. Okay. So it seems some time is left. It's not still 5. So maybe we can go for some GSM theory and practice in short. We'll finish off so that you have one more advantage here of getting a nice workshop, which includes some extra things like GSM. Okay. I'll not take much time in GSM. You already might have heard about GSM is Global System for Mobile, also called Group Special Mobile. 900 megahertz and 1900 megahertz bands are there. It has a switching system, base stations, and operation support system. If you see, these are the terminologies used in the GSM network. I'll just tell you in short how a call works or how a SMS works. So you have a device which sends SMS to BTS, which is a base transmission system, and the base controller system, which is again Airtel. Suppose you are talking to Airtel or Vodafone or Jio. Now it will go to MSC. So your MSC is basically mobile switching and service center. Again, it is your own service provider. Now if you are sending SMS to your own friend who is also in Airtel, then it will come to BSC, and from BSC it will come to a BTS way of, suppose you are in Majestic and your friend is in Whitefield. So from Majestic Tower to BSC, BSC to MSC, and multiple BSCs also may be there, or then it goes to BTS, which is near to Whitefield, and you are sending SMS to him. Okay, but suppose you want to switch. That means Airtel person is sending SMS to Jio person. Then it will come to MSC. From MSC it will switch to NSS. From NSS it will go to other MSC. That means the other company MSC. Other company MSC to other company BSC. Other company BSC to other company BTS, and then SMS will be delivered. Suppose you are doing a WhatsApp message, which is then your friend may be in GPS bone internet somewhere. Your friend may be in US, and you are sending him WhatsApp message via WhatsApp. Or suppose you are making a landline call, then from MST it will go to PSTN and then landline network it will access. Then this is same thing in a very simplified manner. BTS, BSC, MSC. Three thing only is there, and then external networks are there. SLR, VLR in EIR is basically your home location, whether or visit location means you are in roaming, and whether equipment is not stolen and equipment is authorized equipment. Security and balance purpose EIR is used. To communicate with GSM modem, a hardware like this, I hope you can see in the one more this one, the hardware. This hardware which you can see here is basically a GSM modem. 1 second. Okay, this one, this kind of hardware is GSM modem. Okay, it has an inbuilt antenna, a wire antenna, and maybe the antenna quality is little broken here. Okay, what we can do? Fine. And the chip number is SIM 800C, and the SIM is connected here. The yellow color thing which you can see is basically the Idea SIM. Okay. So I have put a separate test SIM for testing purpose. It's not my SIM. It's just for testing purpose. Okay. So what you can do with AT commands? You can send SMS, receive SMS. You can make a voice call, data call, GPRS call, 2G data sending. All these things is possible with the AT command. Okay. So how to communicate with AT command? Just there is a serial port connector, so you can connect serially with the desktop or laptop. Okay, or you can connect via Arduino via serial interface, which is as we have discussed, it is pin number 0 and pin number 1. You can send SMS via that also. Okay, so these are the few AT commands which we'll be using. Like for example, if you want to enable call line identification, simply number will not be displayed, then just ring will come, then you make it 0. CLIP, AT plus CLIP command is used to make 1 means enable the call ID facility, 0 means disable. Suppose you want to simply make a call, ATD, D means dial, followed by number and semicolon, it will start dialing if balance is there. AT plus CMG are equal to 1 is for reading the SMS, AT plus CMGF is for message format, and AT plus CMGS is for sending the SMS. Here, AT plus CMGS. This is the most useful function. Okay. And deleting SMS is AT plus CMGD. So without wasting much time, we will just jump to practical because this is not main part of our thing. I'm just trying to cover some extra things so that this lecture is more useful, especially for those who already know Arduino very well. Okay, so let me get one USB to serial communicator. Okay, what is the meaning? What is the use of USB to serial communicator here? To connect this hardware to this kind of hardware to desktop or laptop, you need a special device called USB to serial converter. Okay, so this part will be interactive. I will be sharing the number to you, so you people can make 1 by 1 call, and SMS you can send, which SMS I will receive on my hardware and I can display on the computer screen. Okay, actually it will get automatically displayed. I don't have to do anything. So this is USB to serial. So this side is USB, back side is TTL communication. So as you can see, I have the hardware here. So my TX goes to his RX and his RX goes to my TX. He will speak, I will listen, and I will speak, he will listen. TXR is cross coupling. So this white wire is RX, should go to TX. Gray wire is TX, it should be RX. So connected. So this is connected here, but both should have common ground. So let me make the common ground too. So now ground also is common. So what I'm going to do is, this hardware is on different place. Okay. So I'll show you. After connecting, I'll show you how I connected. Okay, and this requires one separate power supply. GSM modem requires high power, so a separate power supply is required. The Arduino power is not enough. Okay, now I can show you. Okay, so this is a GSM modem. This is USB, connect to a USB hub. Okay, this phone battery is very low, so maybe soon call cut. Okay, I'll just switch off the camera so that battery is saved. Hope my voice is working. Okay, fine. So let us open one serial program which I can use to communicate with the AT command. So I have a program called, any serial program can be used. I have a program called Hercules. I'll be using that. Allow serial 9600 COM port open. As soon as I click open, it has opened successfully. Okay. Now first command which we can test is a simple AT command without any extra character. Simple AT command we can try. Okay, I type out AT, echo has come AT, means communication is working, wire is okay, physical wiring is okay. Okay comes means device is also okay. Now AT plus CMGR equal to 1. I'm reading the sim location 1. Nothing is there. Sim location 2. Nothing is there. Sim location 3. Nothing is there. So what I'll do is, now I'll send phone number to you guys. You can start sending some SMS. I'll put this number in chat. Okay, this is my SIM test or GSM test SIM, GSM testing SIM number. Okay, so maybe you guys can send SMS on this number. So I'll get the indication here, and same time, see, one message has come. This is the indication. Some message has come in location number 1. So I can read location number 1, but I am not able to read the message. You see, it is in a different format. It is in PDF format. So first I have to change the format. I have to go to ASCII format. So F command, CMGF equal to 1. After giving that command, if I read, why format has come. Okay, now sim location 2. See, hi sir. From this number it has come, hi sir. Okay. Now, but why location number 1 has not come properly? From 175 phone number ending, I got the message, but still it is in. Oh, maybe he might have sent some graphics which is not supported by our ASCII device. So only ASCII message may be supported. Okay, but because we are able to read location number 2. Okay, so I'm getting this, hi sir. Location number 3. Nothing is there. Okay. So I want to delete the messages. So I can go for D. Okay. D equal to 1, I have deleted. D equal to 2, also I have deleted. And again, D, I'll make it R to read the message at location number 3. See here, the one message has come. This is indication. Message has come. See, Namaskara, sir. Uta ita. Yes, I had Uta before class started. Okay. So, see, now this number, what we can do is, I can call some of the students. If they can call me here, that is better. Can you give me a call on the same number? Give me a call on this number. Anybody? One person, but don't try all together.
Yes, sir, we will do.
Yeah, one person only. All try together means it will come engage. So if you call on this test number, we should get some message on the screen. See, this person is trying to call me. Ring and followed by his number. Correct? So what I can do? I can do one thing. I can do ATH and I can send this command. So what will happen? For him it will come as this number is busy and call will get cut. Oh, I think there is a problem in the connection.
No, it's come as busy.
No, but problem has come here. The communication has gone down because I'm not getting the echo. If I send any command, I should get echo. I'll close and open and then send this command. Means see, the black color should come. Pink is what I'm sending, black is the echo, and OK is the reply. Okay. So, okay. So now what we'll do is, one more thing we'll do is, I will try to call somebody, ATD. I try to call this number. Okay. If you get a call, you can cut the call and then you can send SMS to group again that you got the call. So I'm calling number ending with 175. So I hope, I'm not sure whether I'm having balance or not. If I'm not having balance, the call may not go. Okay. So that is a mystery here. Okay. What I'll do is, I'll try to send SMS. How to send SMS? Okay. I got the chat that he got the call. So that means some balance is there. Okay. Okay. So maybe we can cut the call, ATH, and then we can send this. ATH. Okay, so we have cut the call. Now the next thing is how to send SMS. So what is the format for SMS? Where is that PPT? The last slide. CMGS for my mobile number, correct? Okay. So I'll try to send SMS to this number only. Control C. Okay. So SMS goes like this. As soon as I send this command, I'll get a greater than sign. Then I'll type my message. Okay. Send. I got greater than sign. So hello, how was the class? Send. See you tomorrow again. Okay, but how to end? So for end, you have to give 1A. Hexa value 1A for end. If you send this, then message will be considered as a terminated and SMS will go. Error has come. Okay. So maybe SMS balance or something is there. Maybe I have to recharge, but I have very low battery here. Okay. Where is the option to recharge? Mobile recharge. Idea. Okay. View plans. Talk time. Then some SMS plan also. Okay. Where is that SMS thing? Okay. SIM message once something has come, which I have recharged. So we can read that now. How to read? AT plus CMGR equal to 1. This way you read. So you have recharged this one. Okay. Now main account, but SMS we need. SMS balance will do. Okay. Not getting. Okay. 1 day SMS package I'm not getting. I'll try to send SMS again. Okay. AT plus CMG is equal to mobile number. Send. I got greater than sign. Then I'll put message. How is class? How are you? Send. Then hexa value 1A. Hexa value. Error has come. Okay. I think +91 is required. Again we'll try. First we'll try simple AT command. Send. Okay. Then maybe one more number was there. Okay. This number will try to send message. Control V. Okay. Then send. Oh. Close. Open. Send. How are you? Send. Send. Then last is 1A. Error. I think so many days I have not used this SIM, so some facilities are not working. I have to put this SIM into phone and check whether SMS is going or not. Sometimes SMS center number also is getting disturbed. But okay. But we can receive the SMS which we have seen just now, and we can make the calls. So ATD followed by this command, and then call may be going to this number. I can also try now cutting the call. Nowadays calls are not going also easily. First you will listen a long message from the COVID thing, and then only call will go. Now 80. Hang up. Hang up. I'll try one last time for my number. 9986 111439. This is not required. Hello, this is test, and then 1A. Still error is there. Okay. Okay, then we'll stop the class here. If anybody is having any questions, they can ask.
Yes, please feel free to use chat box or open your mics to ask any doubts. If anyone have doubts, please feel free to ask.
So I hope all of you have started some internships and projects. Is how many of you have hardware? Can you write in chat box? How many of you have hardware? Okay. Yeah, 1, 2, 3, 4 people are having hardware. Very good. So tomorrow is next level topic, which is basically on IoT. Okay. So what we'll do is we'll make a IoT website such a way everybody can participate in that. Everybody along with me, you start making the website so that you can also post data. But first we'll make my website. In my website you post the data. Then you start making your own website. That we will do tomorrow. So I think today is Saturday. People want to go out and enjoy the weekend. So we'll not hold them more. So tomorrow we'll meet around 3 o'clock. We'll start the class same time. Is it okay?
Sir. Yes, sir.
So maybe the presenters like me and coordinators can meet 5 minutes to 10 minutes early because setup and all things we'll do before class starts.
Sir, 1 minute. Thank you, sir, for your amazing session. We learned quite a lot of new things. I thank all the participants for joining in again. We are looking forward to having you all in our second session tomorrow at the same time with the same meeting link. Thank you for all. Yes, sir. We
Thank you.
have to
Thank you.
and put an end to the session.